We're going to look at differentiating functions of the form ax to the n. You should know that if y is equal to ax to the n, then dy dx is equal to nax to the n minus 1. Just look at what's happened. The n drops down in front of the a and multiplies the a, and the power is reduced by 1. So, if we had y is equal to 5x to the power 4, dy dx would be the 4 drops down in front and multiplies the 5, so we get 4 times 5, and the power is reduced by 1. 4 5s are 20, 4 take away 1 is 3, so the result is 20x cubed. This works with negative indices as well. If y is equal to 2x to the minus 3, then dy dx is minus 6x to the minus 4. The minus 3 multiplied by the 2 gives the minus 6, and minus 3 take away 1 is minus 4. This also works with fractional indices. If y is equal to 8x to the power half, then dy dx is 4x to the power minus a half. 1/2 times 8 gives us the 4, and a half take away 1 is minus a half. It's worth noting that if y is equal to 3x, then this is y is equal to 3x to the power 1. X has a power 1 on it, which we don't normally write. So if we differentiate, we get 3. 1 times 3 gives us the 3, and the x would then be to the power 0. Anything to the power 0 is 1, so we'd have 3 times 1, which is just 3. If we have any number times x, when we differentiate, we just get that number. It's also worth noting that if y is equal to 3, then this is y is equal to 3x to the power 0. Remember, x to the 0 is 1. So when we differentiate, we just get 0. The 0 drops down, and 0 times 3 is 0. So if ever we differentiate just a number, it doesn't matter what that number is. When we differentiate, we get 0. If we have a function made up of several terms, we just differentiate each term in turn. So if we have y is x cubed minus 3x squared plus 4x minus 5, then dy dx is the x cubed differentiates to give 3x squared. The minus 3x squared differentiates to give minus 6x, plus 4x differentiates to give plus 4, and the number on its own, the minus 5, becomes 0, so we don't bother writing that. So dy dx is 3x squared minus 6x plus 4.